Okay guys, let's start question number 3 of exercise 5.1. Here we will discuss about the third type of the factorization, and the first two we have discussed before. Now we will talk about the third type of the expression which we will factorize in a different way. So here the formula that we will use, that is a squares plus minus 2ab plus b squares, and this type of expression always have the three terms. Whenever you see the three terms, first of all, I've told you the basic step of the factorization is to take common. But here, there is no common. We can't take any common from here. So we will go for the next step, that is to make the pairs. But here are the three terms how we can make the pairs. So after the basic two steps, we will move towards the third one. If we have the three terms here, any of the two terms should be the perfect square. For example, 144a square, that is the perfect square of 12a. Mean when we will multiply 12a by 12a, we will get 144a square. And one more term is here, 1. 1 is also a perfect square. So here the two terms are the perfect square. So the next thing that we will have to check over here, that is we will have to complete this formula. A squares and b square we have written. The next we have to write over here plus minus 2ab. Here there is a sign of plus, I will write here plus. According to the formula I will write 2. Then ab, in place of a I will write 12a, and in place of b I will write 1, and then there is a sign of plus. You can see here the two terms are the perfect square, and we have completed this formula over here. But the next thing that we have to check whether we can use this formula or not, that we will have to check this one. After multiplying these three, we should get this middle one term. 12 2 times 24, 1 times 24a. It means after the multiplication of these three, we can get 24a. It means we can apply this formula. This is a squares plus 2ab plus b squares. So this is the formula of a square plus 2ab plus b square. This is the open form of a plus b whole squares. A plus b whole squares. Mean if we can close this formula as a plus b whole squares, we can also close this. This will be closed as a is here 12a and b is here 1. So this is 12a plus 1 whole squares. You can also write this 2 times. You can also write this in the form of square. So here are the factors. If we want to write this 2 times, 12a plus 1 into 12a plus 1. These two are the factors of this given expression. Okay guys, now we'll move towards the next part. It's in part 2. You can see here again, here are the three terms. We cannot take any common. So we will check for this formula again. There should be two terms which should be the perfect square over here. A square over b square is the perfect square of a over b, and b square over a square is the perfect square of b over a. So I can write like this: a over b whole squares, and this is b over a whole squares. As I have written a squares plus b square. Here always the signs are plus. So here with the formula plus minus 2ab. 2ab, the sign is of this value, this term. If there is minus, I will write over here minus. 2 ab mean a over b, b mean b over a. B over a. Now this is the formula of a squares minus 2ab plus b squares. Again we will close this formula as a minus whole squares. So I can write this a over b. A is this minus b is b over a whole squares. This we can write in this form as well, and we can also write this 2 times. Part 3 we are going to solve after the part 3. Part 4 hope so you will be able to solve yourself. In part 4 first you will take the common. The common will be 3 over there, and then the rest of the expression will be the same type of expression. You can make there the 2 perfect squares, apply the same formula. So here in part 2 are the 3 terms again. This is the first one, this is the second one, and this is the third one. Again we will check for the 2 perfect squares here. X plus y square is the square of x plus y. I can write this as x plus y like this minus, first I will write the value of b over here. 49z square is the square of 7z. 7 times 49, z times z square. According to the formula here is minus 2, a mean x plus y and b mean 7z. Here is always plus. Again you can see here that this is the formula of a squares minus 2ab plus b squares. I can close this formula again. A is x plus y and b is 7z. Here is minus, so this is the formula of minus x plus y minus 7z whole squares. You can also write this 2 times. X plus y minus 7z and x plus y minus 7z. So this is the factorized form of this expression. It's very simple. After this, we will move towards question number 4. Question number 4 is the next type of the factorization, which has 2 terms all the time, and they both terms are the perfect square, and then we can use here the formula of a square minus b square, that is always equals to a plus b into a minus b. So first of all we will check for the basic factorization over here. The first type of the factorization, that is to take the common. So first we will check for the common. The common can be taken from here. 3 and 75 both are divisible by 3. So this is 3. Inside it is x square. 3 how many times? 325 times 75. Now you can see from here that there are the 2 terms and the both terms are the perfect square. Means x square is the square of x and 25 y square is the square of 5y. As this is a squares minus b squares, that is all the time is equal to a plus b into a minus b. A is here x, b is here 5y. So this is 3 x plus 5y and x minus 5y. So this is the factorized form of this given expression. Same like this, we will go for its part 2. Again students, you can see here the brackets. So when there are the brackets, first of all we'll have to open these brackets. So x is multiplied by the x is x squares. X multiplied by 1 is x minus y multiplied by y is y squares minus minus plus y 1 times y. So now I will arrange this. First I will write x squares minus y squares. I will push the bracket, then minus, I will put the bracket x, and this plus will be minus y because we have put the bracket over here ourselves, x minus y. I will use here the formula x square minus y square is all the time equals to x plus y into x minus y, as a square minus b square equals to a plus b into a minus b. Now you can see here are two terms. One is this one and the other is this one. From both these terms, the common is x minus 2. X minus y is here the common factor that we will write as common. From here x minus y is the common, x plus y is left. Minus this is we have taken as common, so here it will be 1. So these are the factors of this expression. Okay guys, the last part that I am going to solve over here, that is 3x minus 243x cubed. They all four parts are the same. But so I skipped here part 3 that you will solve yourself. So here are the two terms again. First of all, we'll check for the common here. The common can be 3 here because 3 and 243 are divisible by 3 and x is also the common. So because x is also present in both terms, so 3 is the common, x is also common. Here this whole term we have taken as common, so there will be 1 minus 3. How many times 243? 381 times, and x cube, from x cube, x is the common, so here is now x squared. Now we'll check, can we take the perfect square of both these? Yes, sure, we can take. This is the perfect square of 1 and 81x squared is the perfect square of 9x. 9 times 81, x times x squared. This is again a squares minus b squares, that is all the time equal to a plus b into a minus b. This is equals to 3x. You can put any bracket here, that is some small bracket or the large bracket. So here I will write this as 1 plus 9x and 1 minus 9x. So these are the factors of this expression. So here we discussed about the two more types of the expression. Here are the two more types of the factorization. So the first was a squares plus minus 2ab plus b square, and the second was a squares minus b squares. How to open this? Thank you.